Hello, welcome back to Learn Physics. In today's topic, we are going to discuss about atoms. Okay, so about atoms in chemistry, you would have learned many things about atoms, structure, all those things. Here, in this chapter, we are going to study about some of the atom models. Some of the atom models we are going to study, and then the physical way of explanations, and see if we are considering some dense gases or condensed matter in solids or in liquids. While we are considering, we know that always it will be emitting some radiations. So if we are thinking about or studying about this radiations, in that radiation includes many wavelengths. Okay, so if we are taking out the light which is coming out from the sodium vapor lamp or mercury vapor lamp, and all those things, while we are considering the radiations emitting from these lights, it includes many wavelengths, not only one wavelength. So a series of spectral lines will be obtaining. Okay, so in this chapter we are going to study about those spectral series and some of the atom model. Okay, important atom models we are going to study. Okay, so first about atom model, while we are telling, say first atom model was given by J.J. Thomson. J.J. Thomson had given the first atom model, that is plum pudding model. What is this plum pudding model of J.J. Thomson? He assumed that the positive charges are distributed among the volume of the atom. Inside the atom itself, all the positive charges are distributed. And inside that, electrons are distributed inside that like seeds in a watermelon. So you can think like a watermelon. The fleshy part, this red color part is like a positive charge. These positive charges are distributed in the entire volume, and the negative charges, that is electrons, are distributed like seeds in the watermelon. That is plum pudding model, which is given by J.J. Thomson. Okay. In J.J. Thomson, as per J.J. Thomson, it is a plum pudding model. Plum pudding model. What is meant by this plum pudding model? It is the positive charges distributed inside the atom and the entire volume of the atom, and the electrons are distributed as a seeds in a watermelon. That is plum pudding model. Next is Rutherford. Actually, the research student, he was doing research under this J.J. Thomson. So next, Rutherford had given model for this atom, that is nuclear model of atom. Nuclear model of atom. In this nuclear model, actually it is a satisfactory. This model had a given a satisfactory explanation about the structure, about the atom. Okay, atom model. It is a very good and accepted model as nuclear model of atom. Okay, so here in this chapter we are going to study about this nuclear model of atom, and while for doing this nuclear model of atom, actually another two scientists whose name was Geiger and Marsden. Geiger and Marsden. These two were doing some alpha particle experiments. Okay, in that experiment, through that experiment only, Rutherford explained his nuclear model. So first we are going to study about the Geiger-Marsden experiment, and then next we will be studying about the nuclear model, and from the experiment how we can explain the nuclear model of atom given by Rutherford. Okay. So the next is Geiger-Marsden experiment. So first we are going to study about the Geiger-Marsden experiment. It is about alpha particle scattering. Okay, so some 5.5 mega electron volt of alpha particle is coming out from the bismuth. Bismuth is a radioactive element. Okay, from the radioactive element, this 5.5 mega electron volt of alpha particle is coming out. So that this is that source of alpha particle. Okay, so that is passing through the lead bricks. Okay, some lead bricks are there. It is collimated through this lead bricks, and which is allowed to fall on a thin gold foil. So alpha particles are falling on this thin gold foil, which is of the order of 10 to the power minus 7 meter. Okay, it is very thin. Okay, this gold foil is very thin, and this alpha particles are allowed to fall on this thin gold foil. So, and here one zinc sulfide screen is kept. Along with that, a detector and a microscope detector also placed. Okay, it is in this circular manner. It is kept like zinc sulfide screen is there. Along with that, one detector, this is along with a microscope is also there. So what will happen if the alpha particles are falling on this gold foil? So gold foil means it will be consisting of many number of atoms. Okay, since it is very thin, the number of atoms will be very less also. Okay, and in his experiments, what they observed is, see, the alpha particles are falling on this atom. So the gold foil, when it is falling, and when they are observing through this zinc sulfide screen and with the detector, they observed that here we are getting many number of alpha particles. Okay, here we are getting many number of alpha particles. That is, if the angle of scattering is very less, that is, for small angle of scattering, we are getting more number of alpha particles. Number of alpha particles observed after scattering will be, see, this is not very small. This angle is small. But for large angle scattering, from here, if we are considering a large angle scattering, it is also less. It's compared to the small angle scattering. Here also scattering is happening, but it is very less. And we can see in some of the points we are not getting any alpha particles. That means it is getting reflected back. So it is coming this side also. In this side also we are getting some of the alpha particles. That means then the some of the alpha particles are getting reflected back, and most of the alpha particles are that's coming out in a small angle scattering. If the scattering is happening for a very small angle, then the amount will be more. Okay, then but here in large angle scattering very less, and 1 in 8,000. 1 in 8,000 only will be happening. If 8,000 alpha particles are scattering, 1 will be reflecting back. Like that he understood. So this is the experiment done by Geiger and Marsden in the case of alpha particle scattering. Okay, in alpha particle scattering, they understood that this is what happened. These are the observations they did. Then next what they did, the angle of scattering and number of alpha particles scattered. Okay, both they connected and made a graph. Okay, next we are going to draw the graph for that. So here, this is angle of scattering. Angle of scattering in x-axis, and here number of alpha particles. Here it is number of alpha particles. So what we observed over here, if the angle of scattering is less, more number of particles are getting scattered. So if it is less, this will be more. Okay, as the angle increases, what will happen? It will be the number of particles emitted will, as the angle increases, number of particles emitted will be less. like that we will get. Okay, so as the angle increases, number of particles emitted also will be less. If the angle decreases, number of particles scattered will be more. Okay, so we are getting, they got like this dot and they connected together and it was like this. Okay, this is the experiment which the Giger and Marsden did this experiment, and using this experiment, our Rutherford explained his atom model. He considered that, see, more number of particles are getting scattered with this one, and some of the elements, some of the alpha particles are getting reflected back. Okay, so some, see, most of them are getting scattered and coming at the center. Number of particles are more there. Number of particles are getting scattered over there. So what he understood that, what was his conclusion? He concluded that then if we are considering an atom, most of the mass is distributed at the center. If most of the mass is distributed at the center, while alpha particles are coming and incidenting over there, and the alpha particles are getting scattered and coming out. And why it is coming out at a small angle? In those angles, there are more amount of free space is there. Okay, in the center. So while we are considering an atom, here more amount of free space is there. So that is why alpha particles can come out from the through this small angle. When we are considering the large angle, so the electrons will be somewhere here and there it will be. Okay, we know alpha particles, it has positive charge, isn't it? So if the alpha particles are having positive charge, see, it will be getting reflected. So nucleus, some positive charges there at the center, that is called as nucleus. Okay, so the positive charge is there at the center, so it is getting reflected back at that position, and with this more number will be coming out, so there are more free spaces there. Okay, so and it has very less electrons will be somewhere here and there it will be. So he understood that the nucleus is at the center. At the center nucleus will be there. That is why at 180 degree it will be getting, angle of reflection will be 180 degree. That means if it is 0 or near to 0, more number of elements are, alpha particles are getting scattered. What are the conclusions made by the Giger-Marsden experiment? In Giger-Marsden experiment, they understood that in the case of small angle scattering, number of alpha particles getting scattered will be more. If it is large angle scattering, number of particles scattered will be less, and some of the alpha particles will be getting reflected back also. This is the observation done by Giger and Marsden. Okay, clear this? So next we will be studying using this model, how Rutherford, using this experiment, how Rutherford explained his nuclear model of atom. Okay. So next one is Rutherford's nuclear model. Okay. So Giger-Marsden did the experiment according to their experiments, and using that experiment Rutherford explained his nuclear model. Okay. So as per the experiment, you are remembering, right? So the alpha particle which is incidenting at a particular angle will be reflected back, and some of the alpha particles will be getting reflected back to the same side, and most of the things are coming to on the sides. Okay, very small number is getting reflected back also. From this experiment, Rutherford understood that, see, the first point is atom is hollow. That means more amount of free space is there inside the atom. That is why here and all, without getting scattered, we know as per Giger-Marsden experiment, most of the light is for small angle scattering. Small angle scattering, we are getting alpha particle like this, isn't it? Here in this side, large angle scattering, it is very less. and sum of 1 in 8,000 is getting reflected back also. So many number of alpha particles we are getting over here. That means to resist that alpha particle or to scatter that alpha particle, nothing is there in their path. So most of the atom will be hollow. Atom is almost hollow, like that he understood. Okay, and his second point is entire positive charge and whole mass is concentrated at the center. Most of the positive charges are at the center. So while we are considering this alpha particle scattering, see some of the alpha particles are getting reflected back. So alpha particles are having positive charge and this nucleus also, so some positive charge is there and that will be helping it to reflect it back. Okay, so the entire positive charge and the whole mass is concentrated at the center, like that she assumed. And then next is negatively charged electrons are outside the nucleus. So because since if the negative charges are here, then there is a chance of coming for the scattering at least, isn't it? But here no negative charges are there, so that is why it is not happening like that. So negatively charged electrons are outside the nucleus, like that he understood. Okay, so these are the conclusions done by Rutherford as per his nuclear model, and he suggested that this nucleus is having a size of 10 to the power minus 15 meter. Minus 15 or 14, like that he suggested. As per kinetic theory, we know it is actually the size is 10 to the power minus 10 meter, which is greater than 10 to the power minus 15 meter. So nucleus is around 10 to the power minus 15 meter, and the size of the nucleus, the size of the entire atom as per kinetic theory, we already studied it as 10 to the power minus 10 meter. So size wise, if we are thinking also, this nucleus can be accommodated along inside the atom because it is 10 to the power minus 10 meter is there, isn't it? So but 10 to the power minus, this is minus 15 and minus 10. Don't think 10 to the power 15. Then 10 to the power 15 will be more, isn't it? So it's not like that. 10 to the power minus 10 meter is the size of the entire atom. So nucleus can sit inside that, which is having the size of 10 to the power minus 15 meter. And so here, while we are considering the interaction between this gold foil and alpha particle, while we are considering, see this gold foil is more mass wise, atomic mass is more for gold. This is more than 50 it will be coming for gold. But in the case of alpha particle means we know it is helium nucleus, He2 isn't it? This is the alpha particle. So gold means it will be more. So it is so heavy. It is more heavier compared to this alpha particle. Isn't it? It's more heavy. So the nuclear interaction will be always exceeding for the gold nucleus. Okay, so the interaction, force of attraction we are considering, we can consider the Coulombic force of attraction, electrostatic force of Coulomb force we can consider, that is F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. That is since we will be considering for the interaction between the alpha particle and the gold nucleus. So it's not compulsory always we should use the gold foil only. Any one atom you can use for the scattering experiments. So these are the conclusions done by Rutherford, and he understood that atom is almost hollow, and the second one is entire positive charge and the whole mass is concentrated at the center. Entire positive and nucleus is having, and it is called as nucleus, and that is its positive charge. That is why we are calling it always who discovered nucleus. Nucleus means Rutherford. Like that only we will say. Because of this reason, he only give a valid explanation for the nucleus. Okay, so the entire positive charge and the whole mass is concentrating at the center. So almost all other spaces almost vacant. That is why we are getting more number of scattered light over there. Okay, then next is negatively charged electrons are outside the nucleus. These are the important conclusions done by the Rutherford using Geiger-Marsden experiment, and this is the nuclear model which Rutherford had suggested. Okay, so atom is hollow and the entire mass is concentrated at the center, which is having positive charge, and that is why we are calling this Rutherford as the who found out the nucleus first. Okay, then next is negatively charged electrons are outside from the nucleus, like that also he concluded. Clear? And then here, if we are considering a perpendicular distance from the velocity vector of the alpha particle. See, alpha particle is moving in this manner. Okay, so if I am considering a perpendicular distance between the alpha particle from the center of the nucleus, to the velocity vector, if I am considering the perpendicular distance, that perpendicular distance is called as impact parameter. Impact parameter is the perpendicular distance between the center of the nucleus to the velocity vector of the alpha particle. So alpha particles are coming and incidenting like that. Suppose if I am considering this alpha particle, which will be the impact parameter, this will be the impact parameter. If I am considering this as the velocity vector, which will be the impact parameter, this will be the impact parameter. So the perpendicular distance between the center of the nucleus to the velocity vector of the alpha particle is called as impact parameter. So if we are considering the impact parameter, when theta equals 180 degree, if I am considering theta equals 180 degree, that is going and reflecting back, impact parameter will be very less or not nearly equal to, it is equal to 0. And if I am considering the other angles, angle of scattering, if I am considering other angle, if it is theta equals 0 means impact parameter will be very less. And if we are considering theta equals 90 degree angle, impact parameter will be more. See, if I am considering the atom scattering in such center like this, then impact parameter will be more in that case. Okay, clear now what is meant by impact parameter and the Rutherford's nuclear atom model. So that's all for today. Hope all of you understood all those things in today's topic we discussed about the introductory part of atom model, that is plum pudding model, and what we will be studying in this chapter, that is what I told you. And mainly we learned about the Giger-Marsden experiment and Rutherford's nuclear model of atom. Okay, and then we learned about the impact parameter also. Hope all of you understood all those things. So if you like the channel, please subscribe and press the bell icon also to get the notifications of my new videos. Okay, thank you for watching. Bye.